Hi everyone, my name is Sam Garza. I'm a graduate student at the University of Washington in the astronomy department. So it wasn't until high school that I actually changed my career ideas. I really wanted to be a doctor. I thought I was going to be a pediatrician. But I took a physics class my junior year of high school, and my teacher was really encouraging. I was doing really well in the class, and she said, well, if you like space, you can use a physics degree to study astronomy. My family and I actually went on a road trip to the Grand Canyon. On the way there, I found a flyer that was for the National Radio Astronomy Observatory. On the back of the flyer, it had an advertisement for an internship through that observatory. And I didn't know if I could get in, but I did apply. Just on a whim, I thought, I'll do it if I get in. And I actually did, and it kind of just kick-started my entire career. They helped me through my first internship, where I worked with them at the University of Wisconsin-Madison. And then I kept applying for their program, and I actually worked at the National Radio Astronomy Observatory. I just kept getting more and more opportunities to do research, and all of them were in galaxies. And once I found galaxies, I knew I was in. I was like, this is my passion. I love them so much. My favorite part of astronomy is meeting other astronomers. It's just one of my favorite things to hear. What makes a scientist? What are their unique passions? How did they get into science? And what interests them and what they're excited about studying next? I'm currently studying the circumgalactic medium, which is like an atmosphere that surrounds galaxies. All of them have them. And this galactic atmosphere, or circumgalactic medium, kind of acts like a train station. It's like a holding place where gas from the galaxy can move into it and then kind of come back into the galaxy again. It's a lot of moving parts. And it's really important to study because it's an integral part of what makes a galaxy, and that is the gas. The gas is super, super important. And to study this medium, it's a little hard. So let's say I have a galaxy over here that I really want to study. So behind it, I want to try to find a light source that can light up this gas, basically like a flashlight. And once this light passes through this gas that I can't see, I use my detector to look at this gas and look for different components of it. We call this spectroscopy. And basically, as this light is coming through this gas is not just made up of nothingness. There's things in there, different ions, maybe like hydrogen or carbon or oxygen, and that tells me a lot about what's going on in the gas. The data that I use comes from the Hubble Space Telescope. It's out in space. It's orbiting about 326 miles above the surface of the Earth. A lot of what I do as a researcher is just using my computer and coding. Not a computer scientist, but being an astronomer is a lot of learning different tools that you can use, and mine specifically is mostly coding to create wonderful graphs and plots that can tell us a lot about what's going on in this medium. So now I'm excited to answer some student questions that they had from our recent field trip at PacSci. So Ryan asked, what makes a galaxy? In the most basic form, a galaxy is a large collection of gas, dust, stars, and their respective solar systems, all held together by gravity. And a lot of these galaxies have a supermassive black hole at the center of them. Ryan also asks, why are galaxies purple? Just like how galaxies can come in many different shapes and sizes, galaxies can also come in many different colors, and this depends on how we observe them. So galaxies that look more purple or bluish in color are actually telling us that there's a lot of young stars within that galaxy. So Olive and Maddie ask, how do we know what our galaxy looks like? So getting a 100% accurate idea of what our Milky Way galaxy looks like is super hard. And so we have to kind of piece together little clues to create the full puzzle of what our galaxy looks like. Our first clue is what the Milky Way kind of just looks like across the sky. You kind of see a bright band of the Milky Way just kind of streaming across. It's kind of a nice structure. It's got lots of different stars going on there, but it's all kind of contained into this band. Because it's in that band, we like to believe it's in a disk, and we're seeing evidence of us being in a disk-like structure. And this was further proved by when astronomers took different pictures of the night sky, directly looking at the Milky Way. And when they put it together in a panoramic image, kind of one that you can take on your phone, it's very similar. When they put it all together, you get a nice thin band of stars. And so that's second proving that we're in a very disk-like structured galaxy. Maddie asks, if a galaxy has an atmosphere, does that mean we can breathe it? So unfortunately, no, we cannot breathe this galactic atmosphere. Earth's atmosphere is made up of mostly nitrogen and oxygen, which is breathable and allows you and me and other organisms to live. But our galactic atmosphere is made up of a bunch of different elements like hydrogen and carbon, oxygen, silicon, maybe a little magnesium. And because we have this mix of other elements in there, we really cannot breathe it. But the galactic atmosphere is super important to the galaxy. So just like Earth's atmosphere, it kind of can protect us and can regulate a lot of different processes on Earth. And we really need this gas for forming stars. If we want to get more and more stars and maybe have more planets, then you need this gas for stars to form, and it happens when the gas comes from the circumgalactic medium, falls back onto the galaxy, cools down, and creates a nice place where stars can be born. Mason asks, what would happen if you fell inside a black hole? Theory says a lot of interesting things can actually happen when you fall inside of a black hole. Now, because the mass of the black hole has been collected down into this tiny, tiny point, gravity is super, super strong. Time is also actually affected when you cross this line. So while you're falling, everything's seeming fine and around you, but while you're looking at things, while you're falling, time would be speeding up, just going crazy fast. You could probably see an intense amount of things while you're falling. While that's happening, time is going nuts. You're also experiencing gravity on your body differently. Because it's so strong, the gravity that's affecting your feet is actually going to be much stronger than the gravity affecting your head. And because of this, your body would kind of get stretched out into a long, thin noodle, and we call this spaghettification. Fox asks, do you get to move the Hubble Space Telescope? So unfortunately, I do not get to move the Hubble Space Telescope, but it has really nice antennas on it that allow it to communicate with other satellites, and those satellites can communicate with Earth, or wonderful scientists that can control when and where it points at things. The scientists find the optimal time and place for when the telescope is for it to observe the objects that you're interested in. And once it does that, they kind of take a little time to process it, and then they'll tell you when it's ready, and you can just download it and start playing with real space data. Thank you for joining today. I love talking through these different astronomy subjects with you and answering your questions. And I just want to remind you that if you're interested in something, keep pursuing it, and it's okay if you change what your passion is. Just find out what your passion is and go for it. And remember to stay curious.